Ok, vamos começar, são 1h30. So good afternoon to all. Let's start with this class. So we are going to work on part 13, as you've seen in this morning's class. And perhaps to start, I can ask you if you have some questions. I know Sarah has one, right? So perhaps you can start, you can share, and then we try to help.
I have problems with the WRF with the macro because it's using the laser visual. The teacher was using like this in the video and like this.
So we include macro and then yes, something like, okay.
So first I will launch the Gazebo.
Okay. You are already quickly for search, good. Bring up the flames.
Red.
Red, okay.
It gives me various mistakes, but the problem is that one. And the find substitution argument.
I have the same problem. I think I can help you.
Okay, I think Manuel can help.
Go to your PyCharm, to gazebo.micro.chakra. The image is not changing for me. Are you?
I'm already seeing the Gazebo. No, I'm seeing this web chakra. Manuel asked for gazebo.chakra.
Yes,
Yeah,
exactly.
Okay, yes. It's slow.
This is the macro. The chakra is.
No, but it's the macro. You have to, because you haven't replaced the places where there were arguments, you haven't replaced them for parameters. So you have to search, you can do Control F and search for ARG. And then you'll have to replace them from the way you are doing the player caller, which is with a $sign and chavetas. I don't know how it's named in English.
Brackets, I think.
Brackets, okay.
I think it's curved brackets.
The screen sharing is really slow for me, so I cannot see what you're doing.
Looking at the Gazebo chakra, not the macro.
I can change.
Okay, so it's not slow. You were.
I can't hear. I'm trying to use the phones.
Okay.
But did you understand what Manuel suggested, Sarah?
I can't hear.
I don't know.
Yes. I'm trying to put the earphones, but I can't hear.
Okay, Manuel, I think she cannot hear you.
Yeah, I understand. I can hear her, but yeah.
I think you can hear either microphone or microphone.
I'm using my microphone, but my phones aren't working, so I need to use.
Okay, so we are trying to solve a problem and she's having another one. Okay. Anyone can help with the microphone problem, with the headphones problem?
She can see the chat, I think. I'll try to explain it written.
No, you don't have to write it like I can explain because
I'm hearing. I'm using my sound of my PC.
Okay, so
Okay, your
again.
speakers. Okay. So you were using, because when we weren't using the macro, we were using arguments, but now we are using parameters. So the syntax is a little bit different. So what you need to do, you need to find where the arguments are defined. You can do Control F and then write arg, and then you'll find the arguments. you can do it. No, just arg, ARG, right? ARG. And not the first three ones, go, yes, exactly, to the down arrow. Over there. Now you need to replace the syntax. You need to erase the ARG and replace the parentheses with brackets, yeah. And you'll need to do that on the laser visual and on the other visual that I don't remember, camera visual, I think. I believe there are 3 instances of that.
Yes, there are 3, but I also don't remember the name of the
yeah, but search arg and you will replace them.
Yes.
And I think it will be solved. At least it was for me.
With Gazebo, my PC is very slow also, so
yeah, it doesn't help.
It's a little hard.
Okay, try again.
No, it's working. I took out release just to test the macro.
Okay.
Yes, now it's working. Thank you.
No problem.
Thanks, Manal. Okay, that was your question.
Yes,
Okay.
that's
Any more
all.
questions? No one else needs help? Okay. I could try to start again with the driver from the theoretical class. I can try to finish it. In the previous practical class, I already found the problem, but perhaps I can do it again so you can see. Otherwise, it may be, okay. So,
Hi, Professor. Can you hear me?
yes, I can.
Can you help me? Because my RPT is not working.
Sure.
Thank you.
Share your screen, and then I can try to do what I was saying.
Okay.
Qt is not working, that's strange. So, what do you mean it's not working?
I choose plugins and visualization and TF3, but it doesn't show anything.
I'm not sure how to help with this now. Can you do in the terminal run?
Yeah.
It's here. The problems are here. capsule get pointer called with incorrect name, blah, 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 blah.
I tried to Google it, but I couldn't find a solution.
Oh.
I uninstalled Roche and then install it again, but it didn't work.
Strange. So if you do, let me see if I can find the command. Run rqt view frames. No, rqt graph. Okay, can you do a run rqt graph
Run? ET?
rqt graph underscore graph. Space, the same. Let's see if it can launch like this, or if it has the same problem. Oh, still the same problem. So it's not.
Yeah.
Oh, but now it works. The graphs were working for you, or just nothing?
Before, yes, but not nothing else. The plugins, no.
So can you run again rqt?
Yeah.
Because this worked. Qt, perhaps it's your Qt installation. Plugins, introspection, package graph. Not package, sorry, node graph. Can you close all of them? So X for everyone.
Even this one. Okay.
Oh, no, this is working.
Yeah.
Okay, and now close this one and open the TF3. Can you zoom in? Sometimes it's very far away. Scroll your mouse, no?
No, I'm scrolling, but
I don't know. The only thing I can do is try to Google your error. Show me the error again. RQTTF3. So. I'm Googling. So did you find this? There is a direct Ross answer talking about this. Did you check this one?
I'm not seeing your screen, Professor.
No, I put it on the chat.
Ah, okay. So,
This is
no.
that's strange. I'm not sure this is the same problem as you. Roche 2.
Fine.
No, I think the only thing that, no, I don't think it's the same that you were showing. Perhaps you can create an issue with the information, because now I'm trying to remember what I saw in the terminal, but you should copy paste it to the issue so we can search, okay?
Okay. Thank you, Professor.
Yeah, better to create an issue and let's try to understand what was happening. I'm really not sure. Never seen it before.
Yeah, okay. Thank you.
No problem. One more attempt. Just one more thing. Sudo apt get install qt. Can you do a sudo apt get install qt?
Sudo apt
Get install qt.
qt.
Sim, qt. Tab. No.
Ah, okay.
Tab.
Yeah.
qt5. And then what I cannot see because of Zoom. It's hidden by Zoom. Can you do? Yeah.
Oui.
Oh, qt5. So many things. No, this is not qt5.
Okay.
Something. qt5. Star. Okay, that's it. Star. Enter. You don't have space problems in your computer?
Space? No.
Okay, so enter. Install all this. Because sometimes it's because of the Qt version that is installed. Operação inválida. I think it's apt-get, not apt-get. I'm not sure if that's the problem. No, it's not.
Without
apt.
the spaces.
Yeah. Okay. Next. Okay. Okay, install this part. While it's installing, let me tell you something about what you just did. It said something like this. Do you want to proceed? Just a moment. It said like this. Do you want to continue? S-N. So the S was capital. That meant that if you pressed enter without saying S, it would select the default option, which was this. Okay.
Okay.
say S, enter. If because S is the biggest one, you just push enter.
Okay. This is it. Okay.
Now I'm not sure if RCP is still on your computer, but perhaps you should put it
No,
down.
I close it.
Okay, so let's try again after installing this. Although I'm not sure that this will work. You can see in my classes that my RQT also has some problems because
Yeah.
it doesn't throw everything on the top bar.
Yeah, we looked in the previous in a previous lesson because my image view didn't work either.
But in my case, I can still do everything I need, so I don't care. But yours is. So open a new terminal, and I will tell you a new way to also see the TF tree. So you can do ROS run TF space, that's the package, space, view frames, that's the node name. Not new, view frames, view frames. Okay, so this node, you can tab. It's better to tab. No, it's not, you don't tab after the space. You tab while you are writing yeah, that's it. Enter. So this node will turn on for 5 seconds, listen to all the transformations in the system, and then produce a PDF. So then, well, if there was no error. But I think it also crashed. Okay, also this avenue somehow is not possible. Do you have GraphViz installed? Sudo apt-get install GraphViz. That you see there, /GraphViz.
Not all.
No. Try to do sudo apt-get install the GraphViz. This GraphViz here. Install. Then you start now tab. Tab. GraphViz is there. You see? Install it. I think you didn't try to correct it. Okay, you did. It's still installing on the other window, so you cannot install this. You can only install once in a terminal. You cannot be double installing simultaneously. So we have to wait for the other to finish. And it's taking a while.
Yeah, maybe you can continue and then in the end of the class.
No, let's wait 3 more minutes or so. I think it should be long now. I hope. Do you have Gazebo on?
Yeah.
Yeah, perhaps you should shut it down so it's faster.
Okay.
So much stuff.
Can I say something?
Sure, Manuel.
Pedro, can you write your email on the chat? Because I think you're on my group on this.
Yeah, sure.
So we can contact each other.
I forgot to put the emails. I will put a new PDF online with the emails. Better like this, no?
Maybe.
I will do it now. So you don't, yeah, better that I do that. Alunos. Okay. I'm putting it the new PDF on e-learning already.
It installed, Professor.
Okay, just a moment, please.
Mhm.
If someone can go to e-learning to check if this is working already, the PDF, just to confirm that you can see it already. Now, in your case, Pedro, so you can install GraphViz in the other terminal.
It is installed, I guess. Yeah.
Are you sure?
Yeah.
Did you do it?
Yeah.
Okay, so run RQT again. That's, I'm not sure it will work, but that was our attempt.
Yeah. I have to.
Turn on Gazebo first.
Yeah.
That was the same problem, no? So I'm not sure it will work.
Yeah.
Yeah, no. I'm not sure. Yeah, create an issue and then let's see, but doesn't look
Okay.
very,
Very good.
no, I'm not sure. Okay.
Thank you.
No problem. Anyone else needs help?
Yes, I have a problem with exercise 2. I think
Okay.
I'll share my
Your
screen. Okay.
And I will check what exercise 2 is.
Okay. It's the one where we use game mapping.
Ah, okay.
I created this launch file so that I don't have to remap every param on the terminal. I don't know if it's well done, because when I go to RVs,
It doesn't work,
I
right?
have a problem.
Yeah, I know why. Can you go back to the launch file?
Yes.
So what we do here is, for example, suppose that your node is called Miguel. Miguel. So you have a node called Miguel. So, and you have a topic called scan. So what you are doing here, sorry, not here. Not, well, bad example from my side. No, it's not a topic called scan. Is you have a parameter, which is a parameter of your node that is called base frame, okay? And you want to call it base link. So you are going to try to convert base frame to something else. And you are going to say something like this. Let's start from the right to the left. You say base link. That's this part here, right? Then you say, oh, but I need to put, before that, I need to put my name. So it's going to be Miguel dash base link. But then you do something else that I'm going to put in blue. You put this under the namespace of your player. So because you put this blue part here, and because the value here is a relative value, how do I know that it is a relative value? Because it is a value that starts with the player name. So that value is resolved to something like Miguel base link. And this is a relative name because it doesn't start with a slash. So because this is relative, what will happen is that because we have a namespace in blue, it will do something like this.
Oh, okay.
Okay? So if you don't want the namespace to be used to put Miguel on the left, you have to make sure that the value there is an absolute value. And you do that by putting a slash at the beginning. So in fact, it's here, it's slash dollar parentheses, blah, 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 blah.
Okay.
Okay, that's the first problem. The second problem is actually not a problem because, okay, so let's go back. So now, look, you needed to map. What is the default for the scan? It uses something called base scan, right? The topic is base scan. What is the topic of your LiDAR? It is probably Miguel / scan. Can you confirm this, Miguel? Do you know how to confirm?
Yes.
Okay, so that's your topic name. And so now you have also to map the topic name from base scan to Miguel scan. So can you go back to the launch file?
I need
For that you use a
add
remap.
another. Sorry?
Yes, it's not a parameter. It's not a parameter. It's a remap. You have to remap.
Ah,
So
okay.
there, for example, here you write, yeah, remap. And the remap syntax is from. No, that's not the same.
Okay.
So you want to remap from base underscore scan to and now yeah, then you can put something like this. Okay, right. Okay, you are going to launch. Okay.
Oh, okay. It's already working.
The Zoom sharing is very, very slow.
Yes, but
Yeah,
it is already working.
Okay, I see it. Can you go back to the code?
Yes.
So you remember what was happening in these three parameters? So my question is, why don't you take away the slash and take away the arg name and just put image? What will happen is that I think it will push. No, in this case it will push, so it has to be like this. So I was saying that you could try to take this part away because you have the namespace, but I don't think the namespace will work like this. So it's good like this, like you have.
Okay. Okay.
So it's working. Okay. Anything else?
Yeah,
Amit?
thank you. What?
Okay. If you needed
Thank you.
something else,
No, no.
okay. Anyone else needs help? By the way, did you guys already put something, a video of your robots driving in the National Robotics Festival or not? In the wiki. No. I'm going to give bad on that. So I can perhaps continue where I stopped in the theoretical class, which was the part about, where's my question? It's not here. The part where we try to do the automatic driver. Let's try to do an automatic driver. So first I'm going to prepare. I know you are not seeing yet, but I'm going to try to do something here, which is to try to I'm going to try to do a backup and go back to the place where I was when I was in the theoretical class. I'm really not so sure where I was. Pois, agora. Yeah, let me share. So I don't remember anymore where I was and how to go back. So perhaps I can do it all from the start again. I think it's easier for me than trying to do to roll back. So let me try to explain you again how I think about the driver, okay? So from the start, from the beginning, we are going to have a class driver, which of course has an initialization function. And in here, we need to do things. The first thing would be to define a goal, pose, to which, okay? That's a functionality where we can say, go here, and it goes there. So the goal, a variable, something like self goal equals, in this case, it is going to be a post stamp. Okay, now we don't know if we have already received the goal or not. So that's what I call goal active. That's a Boolean flag that will allow me to know if the goal is active or not. Second, I'm going to have to publish periodically the information about the speed and so the linear velocity and the angular velocity of the robot. We call that's why we have that I have here. I'm going to search for it. Where is it? It was not here. Let me go here. So that's what the timer does. So I'm going to prepare a timer. It's called every 0.1 seconds. And so I'm going to send 10 commands per second. And whenever this timer is activated, it's going to call callback. So I'm going to define this send command callback. Which must do the following. As you've seen before in the theoretical class, we are going to create a twist message. So my command is a twist message where my speed, so I have a speed. Well, let's do it here. So I'm going to have some decision which outputs a speed, linear velocity, and an angle, which is the angular velocity. Okay, this is my decision. For now, my decision is as stupid as this. I'm going to say my is angle is -4. Okay, that's my decision for now. A very raw one. Now, after my decision, I have to build the command message, which is a twist message, and publish it. Okay, so I'm going to start building my command message. I create my twist, my command message dot linear dot x. You know that the x component is the only one that is used in the linear velocity. That's the speed. And my angular z is the angle. Okay. Finally, I have to publish. In order to publish, I need a publisher. So I'm going to create here a publisher. Here's my publisher. So this is where I create my publisher. So publisher command. I'm going to publish. I'm not going to do this right now. It's confusing. M. Oliveira. Okay. That's my and dot publish. That's where we were around 9:30 this morning. And if I launch this, I believe the robot will move periodically around himself because the angle and the speed are constant. We can try to do it. One of the arenas that, okay, so we start here. And of course, the robot is standing still because it is receiving no commands to move, okay? If we want the robot to move, we have to turn on either the teleop or the automatic driver, which is what I'm going to do now. So ROS run. ROS run. P. M. Oliveira. Bring up the driver. Is okay. So if I launch this guy, it's never send command positional argument, blah, 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 blah. I think the timer's message. Okay, so there you have the robot moving around in a rotation. Slowly because the speed that was commanded is slow, but the robot is rotating. So where can we go from here? So you know that we are constantly sending commands. These commands for now, nothing, because the decision is being blind. And as an output, it has the speed and the angle. If we want to make our decision more intelligent, smarter, we have to add stuff here, right? The first step we have to do is to add a goal, okay? So in order for us to follow a particular goal, we have to have access to that goal, okay? So now we are going to work on creating an input goal, after which we can take a smarter decision, which is to go towards that goal. So how do we receive a goal? As I've told you also in this morning's class, if we have RVs, we can use this arrow here, okay? And we can Ross, topic, echo, move base, move very simple goal. So that's the topic name that RVs has for this message. So whenever I put the magenta arrow somewhere, RVs publishes a message, which is a message of type post stamped, I think, that, if I take a look here, has these fields here, okay? So now I have to receive this message because that's the information I need in order to know where I should go to. So that's my objective, my goal. And for that, we need to create a subscriber, which is what I'm about to do now. So here is the subscriber. It receives the move, subscribes to this topic. The post stamped is the type, and then it calls the goal received callback, which is another function that I'm going to create now. Okay, so the goal received callback will, of course, receive a goal message, which is a post stamp, and the question now is, where should I store? The question now is that we must store this goal in order to be able to use it, okay? So we can do something very simple like this, self.goal, that variable that was there before is now the goal message, okay? So this is just about storing the goal inside the class to be used by other callbacks. By the way, when I receive the goal, I can say that my goal is active. Okay, just so we know that I've received the goal. Now, for example, I can do, using the input goal, a stupid decision. For example, I can say, okay, if I've received some goal, I don't care which goal I'm talking about, I just want to receive some goal, I'm going to move much faster. Okay, so I'm going to move at the speed of 0.9 when I receive a goal and before I do at 0.1. So that's an example of, so you can do a myriad of things using the goal as input. It doesn't have to be a smart thing. So now I'm doing a not so smart thing. Let's take a look. So first I'm going to launch my node. There he is moving around. And now I'm going to publish a goal. So when I publish a goal, it starts moving very fast, okay? Doesn't know where it's going, but it's definitely moving faster. So the whole mechanism has appeared to work, and we just have to proceed. Of course, by doing something more smarter than this. So when we have no goal, that's more or less no goal stop. So I just want to stop if I have no goal. So I'm going to do 0, 0 here. When we have a goal, we have to do something more interesting. So now, the decision could be what I said before. So we have to drive straight forward in a straightforward goal, easiest behavior. So we have to compute the angle that we are going to put in order to turn towards goal. And that's what I've spoke also this morning about the drive straight. Again, is drive straight behavior. drive straight. So what we need in order to know how to drive straight, I need my goal, and I would need also my, for example, minimum speed and my maximum speed, just to have some limits on the speed. Let's say that the minimum speed by definition is 0.1 and the maximum by definition is 1.0. Okay. And my outputs should be, so I can actually do something like, oops, sorry. I can actually do insert, that's it. My outputs should be return, should be the angle and speed to use as command. That's the outputs of this function. Okay, so now, if I have a goal, first I must transform this goal to the base link, as I've explained to you this morning. Did you understand my explanation from this morning or not? Because it was very fast. Go ahead. We can test it, but there is something missing in your question or in the behavior that you are trying to achieve. If you want the robot to stop or to behave as if there is no goal, once the goal is reached, you have to put this variable back to false. And right now we are not doing it, right? So we would have to have some form of to say, okay, and if no longer, okay? But let's do it after we are moving towards the goal. If you understood what I meant by the transformation of the pose into the base link of the robot, then I can copy this part and explain. So what does it do, this part? It is going to try to do a transformation between the goal that is given and the target frame, which is the PM Oliveira base link with a slash here, nothing. Okay. So it's going to listen to transformations in order to try to do this transformation, to transform this pose, and this pose will be goal in base link. Okay, so if it fails, could not transform from, and I have to see, this is goal to, yeah, let's define here a target frame equals this, and my target frame will be, it's already there, the variable, okay? So here I just have to put my target frame. Yeah. Okay, so reviewing, we define a variable called target frame, then we try to transform the pose just to see if we can. Just see if you can now, because we need the pose defined in the base link of the coordinate frame base link. So if we are able to transform, we continue. Otherwise, we just say error, and then we return. And I told these two, this function drive straight was supposed to output the angle and speed. So in this case, it will output two things, none. So I don't know, so none, because angle is none and speed is none. If everything works fine, the exception doesn't occur, and we can proceed. In that case, we are going to do something like here. We are going to pick up the x coordinate of the goal. So that would be, I don't need this, I think. Goal in base link dot pose dot position dot x y Okay. So I'm just picking up the x and the y of the goal. And now I'm going to use it in order to compute the angle. So the angle is no more than math.atan2 of y over x. That's my angle. And the speed, it depends, of course, but for now, let's just set the speed to the minimum speed. Okay? Or let's just say the speed is 2.5. Now, so this is a decision of speed, which is blind, once again. We are going to do something better later on. But right now, I can already try to see if the speed is within the predefined limits of maximum and minimum speed, which were given as arguments. So I can say something like this. Speed equals the minimum of speed and maximum speed. So if you're bigger than the maximum, you take the maximum. And if your speed is, or in this case, bigger than the minimum, you take the minimum. Okay? This is just saturating speed to the minimum and maximum values. Saturate speed to minimum and maximum values. Okay? So in this case, I think the speed will always be 1, and 1 is too much, so I'm going to put here 0.5. All right, so this function drive straight, I think already does what we need. It picks up an angle, then computes the speed, and now all it needs to do is to return the angle and the speed. Okay? But now, when do we call this function? We call it when we want to decide. So the decision, as we've seen before, is something that in this case already receives as input the goal and will output the angle and the speed. So if the goal is active, my angle speed will be to self.drive straight. And here I need to give it self.go. Okay. You've seen that this function here can return the none for the angle and the speed. So if it does return none, I think there is no problem because Gazebo will just probably the equivalent of thing and wrong with the decision. Let's stop. Okay. Stop. Okay, so I think we can try it. Actually, I will put the other, well, it's still moving around. Okay, let's try. So it stopped, and that makes sense because the behavior now should be this, no goal, stop. So it is stopped. Now I'm going to put a goal. So when I release it, it is going to publish the goal. And something went wrong here, let's see. Oh, okay, I forgot the part about the TF buffer. So this part here, if I'm going to transform, I need a buffer. And this buffer does not exist, okay? So this self-TF buffer does not exist. I need to create it first. That's these two code lines. So let me create here on the initialization. Sorry, like this. Okay, new attempt. Okay, now let's create here a goal. And we are moving towards the goal, okay? We can create here a new goal. And there, oops. I think it's overshooting. It's moving too fast, I think. I'm not sure what's happening here. Actually, it's saying could not transform PM Oliveira DOM to PM Oliveira base link. I don't know why. Again. I know what's going wrong. Yeah, the problem here is a tricky one. This is a complicated problem. I'm not sure exactly how I can explain it, but let's try to explain it like this. So suppose that we have our robot here with we have our robot here X, Y, and I'm going to give a goal there. So that's my goal, and this is the robot. So that's the base link. And this is the ODOM. So this is the ODOM frame. This is the transformation between these systems. All these transformations have a time in which they are valid. So typically the transformation is only 5 seconds or 10 seconds of length. So if I give you some goals, which is now at second 10, when I reach second 2025 in time, at some point it will not know how to transform these things. Let me draw it in another way. Take a look at this timeline and this frame. So this is the transformation from the ODOM to the base link. Okay? So if I give you a goal at second 10, let's say this is second 10, and I give you a goal here. So this goal has a pause. So the goal will have a pause at second 10 seconds. Now I'm proceeding in time, and over time I'm receiving more and more transformations between the ODOM and the base link. So I'm receiving something like this all the time. The problem is that my node will not store this forever. It will only store for a given time. So for example, if I'm here, my window of transformations that I store in the past is something like this. Okay? So at some point after the second 10, my goal will be very much in the past so that it's out of my window of storage of transformations. Does it make sense? Okay, so the trick here is, because we know that the goal is with respect to the ODOM frame, we know that the goal does not move because the ODOM is static. And that's why I told Manel that we still need to do that check. So because we know this, we can safely say, okay, no problem. The goal, whenever I want to do this calculation, I will pretend that the goal is a present time goal. So I'm just going to change the timestamp so that I can compute the transformation, because I know it does not change over time, okay? The way to do it is like this. So where am I transforming the goal? In the drive straight. I'm trying to transform this goal. So I will transform a copy of that goal. So I'm going to do copy equals, let's say goal present time. Okay. now I'm going to change. Okay. That's what I mean. Let's see. Okay, so you see what's happening now. Okay, now it worked. Let's do it again. Let's go here. And now what's happening is what Gabriel anticipated. Let's do something first because it makes it much simpler, which is we go here to RVs and we add a pose. And this pose is of the so this is RVs publishing to himself the way simple goal. Okay, so if I post, so you can see that the robot is constantly trying to be around. Would make sense, right? So Gabriel, what do I have to do to change this? What do you suggest? So you can see here the code on the left. Sorry. Okay, so I explain again. So, can you see my RVs now? Oh, that's slow. Okay. What time? So you see where the robot is moving around? Around the base of the arrow. That's because it reached the goal and now it's just moving around. Sorry, I have to turn on the driver. Driver is not. Okay, do you see the robot stop? Yes. Okay, new goal. It moves there. Once it gets there, it continues. So now you're going to tell me how I objective I've already achieved. What should I do in the code? Okay. Okay, that makes your first one better. Let's go for the first one first. So can you say again the sentence? The first sentence. Speed to 0. Okay, so and now, how do you replace when the goal is achieved by something that you can program? What does it mean the goal is achieved? It is not goal equals to, so I have here, so you are saying, so the only thing I'm going to do here is print if the goal is achieved. So we are just going to print, do nothing else, just to see if our detection of the situation goal achieved is correct. So you say self.goal equals what? Yeah, to goal active, well, goal active, no, but goal active is a Boolean flag, You cannot say oppose stamp is equal to a Boolean. Well, anyone else has any suggestions? And you keep on thinking about it, Gabriel. Any suggestions? Let me see how many people are at home. Okay, so what I is that if we have a goal and if we have our robot here moving around, you know that the robot is the base link, right? So why don't we, well, actually, we already can transform the goal into the position of the base link. So that way we can also compute this distance. Let's call it distance to goal. If we can compute the distance to goal, if it is smaller than something, that means I'm close enough. So achieving the goal is being close enough to it, I would say, no? Close enough, of course, that depends on the threshold, but if we compute this distance, then we are in a, then we can do something, I think. So let's try to compute the distance to the goal. So drive straight, so let's do a function. Def compute distance to goal. Of course, I will need a goal. And like I was doing in the drive straight, I need to do this transformation. Okay, I need to do this transformation. And now the distance is what? So distance equals math.ask sqrt x square plus y square, the norm. And I just return my distance. Make sense so far? Okay, so I'm computing distance to the goal. And so this is just about computing the distance. And I'm going, where was our code for the decision? Here. Okay, so we are just trying to detect the thing. So instead of this, I would do this. Distance to goal equals self.compute distance to goal, and this will be self.goal. Okay. So if my distance to goal is smaller than, let's say, 30 centimeters, rospy.log warn, I have achieved my goal. Okay, let's try. I have to clear. Okay, let's try. Okay, wait, we have some problem here. I'm really not sure what happened here. Invalid argument passed to lookup transform in argument. I think this is in this function here. Yeah, okay, so we only do this if the goal is active also. If the goal is not active, we shouldn't be trying to compute the distance to the goal. Verify if the goal has been achieved. Okay. Next, new attempt. Okay, so now we are, I can clear. So now we are just waiting for a goal. So the robot doesn't move because it's waiting for a goal. I'm going to give a goal. It is going to start moving there. And once it gets there, it says, oh, I got it. I'm there. But still continues to move. Right? So that's the part. So when you think of doing something, if something else happens, first you think of the something else happens. So you need to detect the situation. That's what you put on the if. And now you are going to suggest what I do after I detect. So what should I change here to make it so that if I've achieved my goal, I should stop moving? Do you have a suggestion, Gabriel, or someone else also? There are many ways to do it. I'm thinking of one. Okay. On which line? Go ahead, Sarah. You have to speak louder. Yeah. I would prefer to do as Sarah suggests. We have this flag, go active, for this purpose. So we just say, oh, the goal is no longer active. And then the behavior that derives from the fact that the goal is no longer active is already programmed here. Okay. Of course, so I would prefer your suggestion, but the way this code is not so easy because if you put here, you are already inside the if goal active. So what I prefer to do is this. I think is the best solution. So this is the verification if the goal has been achieved. Self.goActive equals false. So if I verify that my goal has been achieved, my goal is no longer active, and because it's no longer active, I'm going to have the behavior for when it's not active. So define driving behavior according to the goal. Okay, so this is nice. There are many other ways to do it, of course. New attempt. Okay, so now I can say, come here. Okay, and it is here. And go there. I really like this stuff. I think this is really nice. The robot moving. And it is there. Okay, so it's working. Now, you said something else that was actually quite interesting, Gabriel, which was the second hypothesis. You were saying, perhaps I can slow down once I'm getting close to it. So that's where we can try to change the speed, the linear speed of the robot based on the distance to the goal. So you can see here that our driving behavior, drive straight, defines a pretty constant velocity, linear velocity, which we call speed. So we could also use the distance to the goal in order to define a velocity, something like this. Define the linear speed based on the distance to the goal. So we could say, so we have there, we can compute this here, equals math.asurt of x squared plus y. And we can say, for example, that this is the distance. Of course, here we would need some kind of compensator constant, something like it's just a scaling parameter, which could be 1, by the way. But I've tested, and I think 0.5 is interesting. The saturation continues. The saturation now cannot be like this, because if my minimum speed is 0.1, that means I will never stop. But that's what we want. We want to never stop unless we are in the behavior inactive goal. So I think that does the job. New attempt. Let's go there. And now we start moving slower, and we stop. We go here. Okay, and we stop. You know why it didn't stop exactly on top of the base of the arrow? Because we gave some kind of tolerance here when we set under 0.3. So if we set here under 0.05, that's 5 centimeters, I believe. It will always be, try to be much closer to the arrow. Let's see if we can, here in my RVs, use 0, okay, let's go here. Okay, makes sense? Now, how can the game? In the game, what you will need, what you are going to do is to be hunting. And to hunt, you need something like this. For example, suppose that you are the red. Or let's suppose your robot is green. If your robot is green, you are searching for blues. So, for example, if in your image you see some, oh, I don't, I'm here, yeah. So if you see some blue in your image, you can process the image in order to figure out where the players from the team that you are supposed to prey on are, and that way you can define the angle based on this. For example, if you have an image like this, and if the blue is there, the blue is on the left side of the image, so that means you somehow need to turn left. I don't know if it is 30 degrees left or 50 degrees left, but it's like a controller, once again. You have you can just do a proportional compensator to go and try to put the blue part in the middle of the image. So with this, you can already hunt, because hunting is nothing more than finding out where your preys are and driving straight towards them, okay? So it's the same as what we are doing here, but the goal that I'm setting here manually in RVs can be set by something in your code. So your code could actually publish a goal to himself, and then it will work like this, okay? Any questions? You have to speak all of that. This football, yeah, I can. No, because I looked, so I have something called JPEG, and JPEG is, where is JPEG? Come on, JPEG. Ah, it's here. I cannot, this is always on top. Okay, so now JPEG. The other one, okay. So this is JPEG. This will tell you the color value. And I'm going here and where was it? Number 1, space. So you can see that this color 1 is actually 0690. The green players are should have 0 to 155.0. So it's easy to detect the difference, okay? Actually, that's, well, we can do better than that. We can actually launch a new player, which is a green player, or launch, P. M. Oliveira, bring up, TP, player name, no, bring up, player name, yeah, player name is green 1, player color is green, okay? So you can see here that we've launched a green one, which is here. So now I'm going to put the green in front of the red. Okay? And this image should be changing. This is, yeah, this image should be changing. Why doesn't it change? Did I make some mistake? Could it be the red in front of the green? Yeah, it's the red in. Oh, okay. I was putting the green on the back of the red. So now the green is in front of the red, and you can see here the image. So it should be easy to detect. Well, let's see. Number 2, space. Number 2 is 138.1. I think you will be able to detect it. If it's not possible, of course, I will put down I will change the color of the field. Okay. About this question of these arenas, I'm not sure. I didn't show you yet all the arenas, did I? I don't think so. So we will have also 2 other versions of the arena. Which are the following. So this is arena 1, then we have arena 2. Okay, so it's the same but with more walls. So this is a maze. So of course now your robots must be a bit more intelligent if they want to navigate this. So it's not just a matter of seeing the blue and driving straight forward. You need to be more intelligent. You have to turn around, to turn the corner. You can put the sensors wherever you want. So your robot can have more than one sensor. For example, Bruno today asked if the robot could have a camera looking at the back because you want to know if you are being hunted. Okay? So you could have a camera pointing backwards. And this, of course, will create much more interesting games if the robots are intelligent, which is not easy to. Okay, and also something that could be very interesting is to cooperate. So teammates should be able to cooperate somehow. Because, for example, suppose that you have a robot which is a robot here, okay? That's a prey robot, so you want to hunt it. You are a sphere and you want to hunt this guy. So you are going to pursue it, but if he's smart enough, he's going to run away. And he's going to be running away more or less at the same speed as you can drive, because we are all turtle bots. So you won't be able to catch him just by going after him. So what you could try to do is to tell someone in your team, okay, try to block this path, try to come here, okay? This is very difficult to do. I've never seen this being done, but that would be really nice to see this kind of behavior. Because this is already a swarm behavior. This is not just individual behavior, it's from the collective. This requires that you know where you are. So the robot sphere 1 must know where it is. It must know where the prey is with respect to him. And it must also know somehow where the other sphere is. And this is quite complicated to do. It's not so easy. Did you see the robotic soccer there in DETI? It's a lot of this kind of stuff. And it's really impressive. In terms of rules, what we do when we are trying to hunt, for example, let's say again that the sphere is hunting the cube, and so the sphere is moving towards the cube. Once the sphere touches the cube, so our idea of hunting is to touch. That's why we are going to learn about contact sensors in Gazebo. So Gazebo can also say when the body of a robot is touching some other body. So when a contact exists, there is another code which is continuously also operating. And what it does is to say, okay, so if the sphere hunted the cube, one problem would be that now what would happen? you would, so the sphere would still be hunting cubes, and the cube would be here forever, being continuously hunted until the end of times. So in order to make the game more fun, what the referee does, this automatic node called referee, is to say, okay, the sphere hunted the cube, that's +1 point for the team of the sphere. And the cube is going to be warped to no man's land, to a limbo, which is this, okay? So the players who die, who get hunted, are going to be there for some time, something like 1 minute or half a minute, and this guy will say, oh, now I have nobody to hunt, let's try to move forward here. Oh, I see another one to hunt there, something like this. And the other guy will stay there for a minute. After a minute, the referee will say, okay, let me randomize a position in space where I can respawn this robot, and it will pick it up and put it here. And now the game will continue. So the robots that we develop, so the intelligence, when they are put there, they are still playing. They think they are playing, but in fact the referee is saying, oh, you are in the limbo, so I don't care about what you do. You can be here catching red robots, but it doesn't count. Only the referee knows it. The robots themselves, they don't know it. They are just trying to hunt or evade, but that's it, okay? So there is, yeah, this is number 3, I think. This is number 3 in terms of the arena. What else? I'm not sure what else I can tell you. I think you need a lot of time to program, more than time for me to speak. So, you have any questions? No? What do you mean? That's not a good strategy for hunting, no. No, for hunting, that's not a good strategy. That's a good strategy to go to a place and stop there. What, Rafael? Tell me. Nothing? Okay. You were looking at her like, what are you doing? Yeah, that's it. Or either faster or at the same speed. Never slow down as you are getting close to the target, I think. So I wouldn't do the speed controller that we did here. That's for something else. But you can, if you could somehow mix both functionalities. So for example, if it would be possible for our robots to be hunting, but if they receive a goal to stop hunting and go to the goal, that would be very nice. So our robots are hunting when the goal is not active. So that's hunting behavior right there. Of course, that's not so simple as that. You have to put something there. When the goal is active, you are not hunting, you are doing something else. You are moving to the goal, okay? So there is a lot of stuff you can do, a lot of stuff. I'm going to put online, perhaps tomorrow, I'm not sure, the new slides for the next class. And the next class is completely focused on the game. So, not this one. This one. This is completely focused on the game. So the idea is that you create a launch file to launch several players, not just one, but several. And then the robots will have to figure out which team are they from, okay? And how to configure the teams. So this is completely focused on the game right now. And the pursuit mode that we've discussed before. And also the contacts. So this is also important to be able to know when someone is hunted. You have to configure the collisions, okay? That's it. Vídeo. Não, isto é dos contactos. Okay, so you can continue to do the exercises, and if you need me, call me. We still have half an hour. Diga, Rafael. Yeah. This is a physics engine. So if you touch someone, there is inertia, there is a ação-reação, there is a, so you collide and you. No, it teleports after contact and it takes a long, the contact is not so immediate, I think. From what I remember last year, I didn't revise it yet, but this is the contact part that we need. And okay, so contact. I don't remember how. Okay, so here in the terminal you are saying if there is contact or not. So no contacts now. And once I drive the green robot and hit the red one, it will say, oh, there is a contact. And the referee is constantly monitoring these contacts to know what to do. But of course, if you go very fast and collide with the other robot, it may be that you can, for example, turn your robot around or something like that. So the referee, I can show you. I think I can show you something about the referee. Okay, so this is, I think, a game with a referee. If I can. Okay, now yes. Let's see. The internet is awful here. Okay. Okay, so I'm the blue robot, and I'm going to hunt the green one, okay? Or perhaps I'm going to be hunted by the red. This is like a suicide, because the red is hunting blue. So this is like a suicide. If I hit red, red hunted me. Yeah, now we are taking a look at the contacts. We are still not touching, or are we? Not sure. I don't remember this video anymore. The internet is awful. Okay, now yes. So look, that's the referee there on the left already. He's already showing the stats and which teams are better and so on and so forth. So now we are, if we put the red on top of the green, for example, the green is hunted and goes to the no man's land for some time. I'm not sure for how long. And red is already with 1 point and green with -1. After some time, the green automatically was placed in a random position, okay? Okay, so this for next week you will have this video. So if you need some help, tell me. Okay. Now I give you some time to think about it and do the exercises. We still have 25 minutes, so I think we can stay here. And if you need help, tell me.
I have a question,
Go ahead,
Professor.
Manuel.
On exercise 3, you have to place multiple robots.
Yes.
You will need multiple URDFs, correct? Or
What you actually need is the instantiation of multiple robot description parameters from the same URDF. So shackles, not URDF, shackles. Shackles are configurable. You can also put arguments there to define the color, for example, of the robot.
okay.
So what I did there was to define, let me show you, was to define first in the bringup.launch, I created two variables, player name and player color, okay?
Yes, yes.
Now, I need to send these two variables. Actually, the player name is not used inside the shackle, just the player color. But in any case, I sent them both there. So where am I creating the robot description parameter is here from the shackle processing of my urdf.shackle file. And I added these two arguments here.
Okay.
Okay, so that's giving to the shackle these two input arguments, sorry. And now these arguments, I can show you my shackle. Where is the shackle? Here. The arguments are here. You can
But
see.
the robot name, is it team hand player for everyone? On line 2
Line 2 of which file?
of the chakra.
Of the shackle, line 2. Yeah, that's irrelevant.
It doesn't matter. Okay.
No. What matters is that this argument player color is then used to set the color of the robot.
Okay.
So the actual name of the robot is going to be given when you spawn your robot into Gazebo. And that part there is within the spawn.launch. And you need to be careful about this because what we had here before was this part here. So this was not using the variable player name, it was hard-coded.
Okay.
And you need to say that the model in Gazebo is named player
After the
name.
player. Okay.
Yeah.
Okay, thank you.
No problem. Yeah, that's cheating. That's yeah. This is like reality. You couldn't do that in reality because that's like asking God where the other place, where the other person is. You have to look and see where the other person is. And that's what you can do by looking at the camera, the light. Yeah, exercise 4 is just for you to understand the allometry and localization. Actually, that's what the referee does. Well, not anymore. Before it was normal. Because before the referee was seeing if you hunted me by looking at your position and mine. Now it's looking at the contact, so it doesn't need the position anymore. Something else I want to talk to everyone about is some students say it is going to be very difficult to do something until the date of 14th of February, which is the deadline, I think. Let's see. So the idea was that you would present on the Psr, on the 14th of February, that's it, okay? But I'm thinking if you want, you can also present on the second chance for the recurso, okay? So you can present on the 4th of March. That gives you a month and a half almost to prepare. I will send an email to everyone discussing this. Something else I want to discuss with you is the following. Some students talked to me and said that if it would be possible, for example, in this class P2, to have less groups. So if you take a look here at P2, well, there is one guy there, but it's mostly this, P2. We have group 11, 10, 9, 8, and 7. 11, 10, 9, 8, 7. There are several groups with 3 persons. The suggestion was to collapse one of the groups and the people would go to the other groups. Would that be okay with you? What do you say?
Sure.
I was saying I could destroy one of the groups and put the people in the other, because the person said that it's hard to do this kind of work with just 3 people in the group. It would be better with 4. So he would prefer to have 4 persons in the group instead of just 3. No, unless I made a mistake. No, let me check. Did I make, well, I'm always doing this kind of mistakes. Let me check. So group 8, you say. Group 8, you say. Okay. Group 8. Where is it, group 8? Wait to. Ok, so. Não, o tamanho do grupo está aqui, Sara. Eu tenho aqui o tamanho do grupo. Ora, o grupo. The new PDF? The PDF? Ok, grupo 8. 1, 2 e 3 está aqui, a terceira pessoa.
Somos só três, sim.
But Sarah was saying that you are 2, you are 3.
No, we are three, yeah.
Yeah. So nobody says anything. I don't think you mind. That's it, right?
Yeah.
Okay. So I will try the group that of the people that talk to me. I will try to put them on the other groups. That's it. I don't mind if you have more groups of 4 than groups of 3. So for example, here for P2, which starts here, we have one group of 3. 6 is the people who don't. 1 of 4. Then 3, 3, 3. Okay, yeah, a lot of stuff with groups of 3. We can just take out a group and put it a group of 4. No problem. So I will do this small adjustment and then republish the groups without trying. So apart from that group, you will be with the same people. You just have one more person if that's the case. Okay, that's it. Mhm.
with not one, but two, for example, to different meanings.
The idea is to parameterize your launch file. So your launch file should have arguments to define the name of the player and the color of the player. And then these arguments need to be passed into the launch file, into the spawn.launch, because there you also need to know the name of the player. And also into the chakra, because it is there that you define the color. Okay? You want me to show you how? Or you want to try? So I can give you a small, okay, take a look here. So your bring-up.launch will have two arguments. Okay. Are you watching my screen?
Yes.
Okay, so you have two arguments in your bring-up.launch. Now, you need to pass this player name into your spawn. That's how you do it. You put here the argument. So an argument.launch will contain the value of the argument of the bring-up.launch. And then the spawn will, you need to use it for, oops, sorry. Here, you need to use it to put here the player name when you create your model on Gazebo, okay? Because before it was something hard-coded here, so that's no good. Now, then the color, you will need to use it to parameterize your chakra. So your chakra, which is here, will now contain two arguments. In fact, you only need the color, but I put them both. You will need the color here, and you just put the color like this. So you are just using the value of the arguments to define the color of your robot. And so there is only one thing missing is how do you pass the color from the bring-up.launch into the chakra? So in the bring-up.launch, the place where you are loading your chakra is line 14. Before you would do only this. Now you put on the right, which is, oh, there is an argument called player9 inside the chakra, which will have the value argument player name of the bring-up.launch, and so on and so forth. Okay? And the same for color, yeah. No problem. All right, let's go. It's 20 minutes, 2 minutes to 3.5. So do you need something else there at home? No. Okay.
No.
People here. Okay. So have a nice weekend and study a lot for next week.
Thank you. Goodbye.
See you.